Okay, today we're going to talk about mean absolute deviation. The mean absolute deviation is one way to describe the variability, which means how it varies, or how a spread out set of data is, how spread out it is. Okay, so how it goes from one to the other. And we do this by using the mean absolute deviation. Okay. The mean absolute deviation is the average distance that a set of data points is from their mean. Remember that mean is equal, it means the average. Okay, that means that you add all numbers and divide by how many you have. Today we're just going to look at how you calculate the mean absolute deviation. Okay. It's very time consuming and it can seem a little daunting just because there's so many steps, but it's not really hard to do. So the first thing that you do is you find the mean. Then you find the distance each of those data points are from the mean, and then you find the average of those new distances. Okay, so you're finding the mean twice. All right. So to do this first set of data, we're first going to add these all up. So we total them. Okay. And you get 455. And then there's 7 numbers, 1, 2, 3, 4, 5, 6, 7, and we divide by 7. And we get the mean of 65. Okay? And then we're going to use the table to find the distance between each mean. That means that we have to subtract 65. We're going to take the positive form. Okay, whether you have to, the distance is always positive. So 65 minus 61 is 4. 68 minus 65 is 3. There's 3 units in between. 2 units here, 2 units here, 5 units here, 3 units here, and 1 unit here. Okay, so we're just finding how far apart are they from 65, okay? Then we find the mean of the new numbers. So we're going to add all of these up. 7, 8, 9, 10, 11, 16, 19. And we divide by 7 again. And you get 2.9. Okay. So if the situation says a police officer recorded the speeds over the last 7 drivers, and you got a mean of 65, then the mean, each of those speeds differ by 2.9 miles per hour. They're 2.9 miles from the average speed. Okay. On number 2, we're going to find the mean absolute deviation again. It means that we're going to add all of these up and divide by the number there. So we get a mean 21 plus 26 plus 47 plus 44 plus 22. And then there's 1, 2, 3, 4, 5. So 163 divided by 5. You get 32.6. Okay, so we're gonna find the new mean of these numbers. 32.6 minus 21 is 11.6. 32.6 minus 26 is 6.6. 32.6 minus 47 is 14.4. I'm going to write these up here so we can see them a little better. 11.6, 6.6, 14.4, 32.6 minus 44 is 11.4. 32.6 minus 22 is 10.6. Now we have to find the mean of this new number. Like I said, it's very time consuming, but it's not difficult to do. Okay. 11.6 plus 6.6 plus 14.4 plus 11.4 plus 10.6 is 54. Divide that by 1, 2. 54.6 divided by 1, 2, 3, 4, 5. And you get 10.92. It says the number below represents the amount of time that it took Diana to get to work each day. So the mean absolute deviation means that on average, it took about 10.92 minutes more or less than 32 minutes. 32.6 minutes. Okay. I'm going to give you a few minutes to do problem number 3 on your own, just so you can practice it. And then we're going to give you lots of practice, okay? So I'm going to give you a few minutes. I want you to pause this video and then come back and see if you've got the mean absolute deviation correct. You get 18.7. Okay. All right, we're not going to do 4 or 5. I'm going to let you go ahead and get started on your practice for mean absolute deviation so that you have enough time to complete it.